Okay, I'm going to go through this review sheet relatively quickly, just to kind of give you the solutions, but at least talk them out loud a little bit. So this first problem, we have a regular expression, and we want to turn it into a language, right? A set of strings. We're kind of asking, what is the language of this? And remember that that plus means union, and we've kind of got dots in between these BA and Bs. It's concatenation. So the language of this is just BAB, right? A single string union with the set C, which we could also write as BAB, comma, C. All right? For this next one, we've got some stars in there, which make it a little bit more tricky to write these things out. If we want to figure out what the language of this set is, we can do the very straightforward way, which is just kind of turning it using the way the book tells us to convert. You know, dot is concatenation, and so we could say this is the same as A concatenated with the set B starred, concatenated with the set C starred. But what I really want is for you to understand what this means. So this represents this language represents all strings that start with an A and then have 0 or more Bs followed by 0 or more Cs. So if we want to kind of write this in a logical order, I might write the strings of length 1 first, and then the strings of length 2, I guess there's 2 of them, A, B, and A, C. And then the strings of length 3, so let's see, there would be ABB, ABC, and ACC, and so on. For this last one, let's see, can I move this up a little bit? Good. For this, for this last one, this says that you take 0 or more copies of this AA and then always end with an AB. So again, doing the direct translations into sets, we could just use the concatenation and say this is the set AA starred concatenated with the set that only contains A, concatenated with the set that only contains B. But it's much more interesting to try and think about what does this really represent. So let's write it out. The shortest string in here, and again, I tend to go, you need a logical way to write these things out. Personally, I think the only logical way I can find when I'm doing this kind of ... ellipsis notation is to do it in size order, right? Do all the things of size 0, then all the things of size 1, then all the things of size 2, and so on. Nothing of size 0, that lambda's not in here. Remember, this is telling me that I need to take 0 or more pairs of A's and then end with AB, so the shortest is just going to be AB. The next shortest will be AAAB. The next shortest will be take 2 pairs, and then the AB, and so on. So now we need to do this the other way around, right? We need to take languages, sets of strings, and turn them into regular expressions. This first one is really very easy. Remember that union is plus, right? And that this set is actually equal to that unioned with that unioned with ABBA. So the regular expression for this is simply B plus ABA plus ABBA. Okay? This second set, we have Rowan unioned with profs R, tops, and we're concatenating the two. Let's turn this into something slightly different. This is actually one set, Rowan, profs. And then we need to concatenate that, so we need to kind of squish that up with the R tops, right? Let me squish this whole, oops. Let me squish this whole screen down a little bit so we have some room to work. So we have, remember that this all should actually be on one line, all this blue stuff, right? And so what we're saying is really, sticking with set notation, we're saying take one thing from each of these and then follow it with one thing of each of these. So this would be the set that contains Rowan R and Rowan tops and profs R, right? Because we're just concatenating one from the first and one from the second. And prof tops. Right? And there's a couple of ways you can write that as a regular expression. One way is to just list out all four of those. So you could say Rowan R. I apologize for my handwriting here. Writing with the stylus on an iPad is not trivial. Plus Rowan tops, plus, this should all be on one line, plus profs R, plus profs tops, oops, no space there, can I hit undo? Beautiful, plus profs tops, okay? So that's one way to write the regular expression. A simpler way would be to go back to something that looks more like this expression that I have, which would be to write Rowan plus profs. Let's just draw a line so you can see where this breaks up. Rowan plus profs, concatenated with, I'll give you the dot here, usually we don't write that dot, R plus tops. So what's really important is that you look at all of these and you understand what each of these means, which is a set, right, which is a language, which is just a regular expression that represents the language, and you should feel comfortable moving back and forth between these. All right, let me clean this up a little bit and I'll do the last one. Okay, so this last one, dear, I'm sorry, it's since I put it into the slide for using it here, it's gotten wrapped, but it is 0 or more A's in a row, followed by 0 or more B's in a row, right? So if I were to write this out in set notation, right, I would get something like this. I would say, all right, well, I have lambda, and then take one from the first and one from the second. Well, A lambda is just A, and lambda B is just B, so those are of length 1. And then the strings of length 2, they could be AA followed by lambda from the second set, or A followed by B from the second set, or lambda followed by BB from the second set, and so on, right? But really, it's actually much easier to just take a look at these two representations of the set and turn that into a regular expression. This first set is actually also equal to the set containing A starred, right? And then we are concatenating that with the set containing B starred. And so if we turn that into a regular expression, we just get A star followed immediately by B star, right? Concatenated with B star. And usually we leave out the dot, but there is a dot in there, right? Now, simplification is kind of in the eye of the beholder. You just kind of mess with an equation until it looks a bit simpler. You can decide when you think it's simple enough. It is a little bit of a judgment call. The important thing to know is that with regular expressions, the kind of mathematical rules of precedence that you think exist do apply. And so, for example, I can take this first piece and say, well, that's actually ABB plus AABB plus AAB. And I tend to say colloquially, I'm multiplying it out, even though, of course, you're not multiplying it out. It's just a property of regular expressions that you can do that expansion. And then we will have that plus. And again, I'm going to kind of say that I'm multiplying out, but really I'm just expanding this. The second piece is ABB plus AABB plus CAB. And then we'll stick in that little plus sign. And the last bit, oh, well, that's a concatenation, and there's just one string in the first and one string in the second, so we're just concatenating it with BAB CCB. Now, if you look at this, remember that plus is equivalent to union, right? So this is effectively the union of all the strings represented by these regular expressions. So in fact, I can get rid of duplicates. So here I have ABB and here I have ABB, and those are the same things. Unioning something with itself doesn't matter, so I can kind of get rid of that. And then I have a double A, double B, double A, double B, so I'll get rid of that one. And so it looks like I am left with ABB plus AABB plus AAB plus CAB plus BABCCB. And you know, if you want to, you can mess with this a little bit more and try and simplify it more. So maybe I take out all the things that begin with AA. You know, I've got AABB plus B. And then, so that's taking care of this one and this one. And then the rest of them end with a B, so I could say that's plus, let's see, AB plus CA plus, ooh, let's go to the next line, AB plus CA plus BABCC, all ending with a B. You know, is that beautiful? No. Could I combine these guys since they both end with a B with this? Sure. Basically, the idea is let's try and get rid of some of the common terms. This is a little bit simpler than the original equation. That's all we're looking for. Okay, so here are just a bunch of quick do you know your definition of a language, an alphabet, etc. questions. So let's do them in order kind of downwards. So remember, an alphabet is a finite set of symbols, right? And so that looks like a finite set of symbols. We've agreed that the letters of the English alphabet will each be individual symbols. So since this one has like 2 A's or 2 B's or 2 C's, we're going to say no, that's not an alphabet. We've also agreed that lambda is a special character that can't be in an alphabet, so not an alphabet. The empty set is also another special symbol, not an alphabet. Boy, this has both lambda and the empty symbol, and the empty set, sorry, not an alphabet. Right here we have 4 symbols squished together in a row. We've agreed that English alphabet letters are in distinct symbols, so this is not an alphabet, and an alphabet has to have a set, and that's not even a set, so forget that. All right. Now let's talk about whether each of these could be language. Right? A language is a set of strings. So as long as we have something that could be considered a set of strings, we say, yes, it's a language. Well, that's a set of strings of length 1. That is 4 strings. Each string happens to be of length 2. This is a set. It's a set of strings of length 1 plus lambda, which is a special string, the empty string, so we're good. This one, however, the empty set is not considered a string, so no. And similarly down here, we've got the empty set, so no. This one here is an interesting one, right? We've just got a single string in there, but it's a set of strings with one thing. And this last one, again, not a set, so can't be a string. All right, let's look at this. Could this be a string? Right? Well, a string is a sequence of symbols concatenated together, right? A finite sequence of symbols. A string is not a set, so the only one that could possibly be a string is that last one, and the last one is a bunch of symbols squished together, so yes, it's a string. Now I say, if it could be a language, is it regular? And we've talked about a bunch of ways to represent regular languages. Right now, really, we kind of know about regular expressions, right? Sorry, we will talk about more, but if we can make a regular expression for it, then it's regular. So this first one is yes, because we've got a plus b plus c. Let me scooch this over a little bit. Oops. There we go. Plus d. Again, this was a language, and we can make a regular expression for it. AA plus BB plus CC plus DD. The next one over here, again, totally regular language. This would be lambda plus A plus B plus C plus D. Let's see. Not a language, so it's not applicable. Not a language, not applicable. That bottom one's not a language. This one is a language with just a single string, A, B, C, D. So that's the regular that is the regular expression for that language. Okay, this is asking for what is the set, and if it's regular, give a regular expression. Well, all strings of length 2 over the alphabet AB, we can just list them. We've got AA, AB, BA, BB, and sure enough, there's an easy regular expression for this, right? AA plus AB plus BA plus BB. Now I'm asking for all strings over the alphabet AB that contain just A's. And I guess this is a little bit ambiguous. It doesn't say whether it could be the empty string. So let's just to make this slightly more more interesting, say all strings over the alphabet AB of length greater than 0 that contain just A's. And so that would be A and AA and AAA and so on. Right? And this is really just the set A star, right? What is A star? So the set A star, this is A plus, of course, but plus is not a regular expression. But A star is lambda A, AA, triple A, and so on. So this first set is just A star without the lambda. And we can do that by saying, all right, well, let me do it in another color. Let me take A and star it, and then add an A to the end. So this gives me, oops, that should be in a set. This gives me lambda time, right, lambda from there times A is just a plain old A. Single A from there times A is 2 A's. 2 A's from there times A is 3 A's, and so on. Right? Now, if the question had not said of length greater than 0, ooh, I didn't finish the question, the previous one. Well, if the question had not said of length greater than 0, then we've just got A star, right? But now, like all good test takers, I go back and look and say, oh, look, she asked me if it is regular, give the regular expression. So let's just make a little bit more room. The regular expression, if we want to insist that the length is greater than 0, would just be A star A Or we could also write AA star, same thing, generates the same language. And if we say, oh, it can be of any length, then we would just say A star is our regular expression. Okay, so this is the trickiest one of the bunch. This says we want to find all strings over the alphabet AB that contain exactly 2 B's. So no more, no less. We know we have to have 2 B's. And if you think about it, we didn't say the 2 B's have to be at the beginning. We didn't say they have to be at the end. We didn't say they have to be next to each other. So really, in terms of sets, what we want is we want as many A's as you want, 0 or more A's, followed by a B. And then squish in as many more A's as you want. You could have 0 A's, you could have a bunch of A's, followed by a B. And then end again with as many A's as you want. Right? So this gives me the string. Let's just look at a couple of strings here. If I want the string BB, I just say take 0 A's here, have to take the B, 0 A's, take the B, 0 A's. If I want the string BAAB, then I would say take 0 from here, 1 B, 2 A's, 1 B, 0 from here, right? And, you know, so now all we need is a regular expression to represent this, and that is simply A star, B, A star, B, A star, right? And of course, I never write them in. You should pretty much get used to not writing them in, but you should be aware that implicit in this notation is a bunch of dots, right? In between everything that you concatenate in a regular expression. We don't usually write them. You're not going to see me write them ever after this review, probably. I don't require you to do them on tests, but just know that they really kind of are there.